This particular number of water molecules that are here is what represents the water of crystallization. Now, in chemistry, most of the times you would heat this salt or expose it to air. If you expose this salt to air and you notice that this particular salt went from Na2SO4.10H2O and maybe reduced to Na2SO4 dot, let's say, 7H2O, please, what does this tell you? It lost water. This particular phenomenon, what do you call it in chemistry? What is it called? Yes, anybody can answer. You don't have to raise your hand, just unmute your mic and answer. A scenario where you expose a particular crystalline salt to air or the atmosphere and it loses its water of crystallization or part of it, what is that phenomenon referred to as? I can't hear you.
Efflorescence.
Efflorescence. Thank you very much. So
Efflorescence.
thank you. So efflorescence, you can mute your mic. Thank you. Efflorescence is basically a phenomenon in which a particular salt or substance loses its water of crystallization when exposed to air. Now, we also know that we know deliquescency now and hygroscopy. Can somebody please tell me the difference between deliquescency and hygroscopy quickly? Okay, let me refer to somebody. Yeah, anybody, just unmute your mic and start talking. Every other person will shut up once you start talking. Yeah. If nobody, I'm going to ask Clement Chijioke. Let's hear you. Clement Chijioke. Yes, what is the difference between deliquescency and hygroscopy? If you do not know, simply say you don't know and move over to somebody else.
Delinquency is when
Deliquescency, yeah, but go on.
okay, is when they absorb heat and turn into moisture, like moisturized
Okay,
form.
first of all is that they don't absorb heat.
Then hygroscopy.
Did you get my correction? What they absorb is water.
Yes, sir.
What they absorb is what? Water. So take note of that.
Water.
Now, when you say deliquescency, everybody is listening. Deliquescency occurs when a substance absorbs moisture from the atmosphere and then turns into an aqueous solution. Okay, go on. Yes, then hygroscopy.
Hydroscopy, they absorb water
Mm-hmm.
and turn into a solid form.
Okay, not necessarily. The point is that they will absorb water, but they will not turn into a liquid solution. Sorry, did you guys get what I just explained? I said in deliquescency, the substance would form an aqueous solution. It will be liquid, a liquid solution, a liquid aqueous solution. But if it is hygroscopic, if that substance was solid and it absorbs water, it will remain solid. It will not dissolve it. So the difference is that in deliquescency the substance is dissolved, but in hygroscopy the substance is not dissolved. If you have seen potassium hydroxide pellets in your school lab, you would have noticed this thing, that when they brought out the potassium hydroxide pellet and placed it on the table, it immediately dissolved. I saw it in school back in the day, and that's exactly why I probably cannot forget it again. I hope what I'm saying is making sense. Class, did you understand?
Yes, sir.
Okay, thank you.
Yes,
Now,
sir.
if you are to consider some examples, probably run through this. Examples of the liquid substance include your sodium and potassium hydroxide, iron 3 chloride, most of your chloride salts, not all of them, but most of your chloride salts, you could say that. Then I've said potassium and sodium hydroxide, these are the popular ones. Some textbooks classify silica gel as deliquescent, but I don't entirely agree. But let's continue. So that's that. Then hygroscopic, the ones that you will definitely come across in hygroscopic is, write this down, examples of hygroscopic substances. The ones you will definitely come across, number one is sodium nitrate, NaNO3, NaNO3. Then you have your quicklime, calcium oxide, you also have H2SO4, sulfuric acid. Now let me ask this question: have you guys noticed that for those of you that have ground sugar in your house, that's powdered sugar or brown sugar. When you leave it open, after a while, it seems as if moisture enters it, but then it does not form a solution. How many of you have noticed that? I'm asking a question. Respond if you've noticed it. You leave your sugar open, after a while, it will be as if moisture, the sugar is somehow wet. Yes? How many of you have noticed it? Exactly. Now, you will notice that the sugar did not turn into a liquid solution. Hence, is sugar going to be the liquescent or hygroscopic? The person that noticed it, I'm asking. Is it going to be the liquescent or hygroscopic?
Hygroscopic.
Exactly. So that's that.
Hygroscopic.
Thank you very much. Please, it's hygro, not hydro. So put that down as another example of sugar. Put sugar. You will notice this in mostly in glucose. Those of you that had took glucose during interhouse, if you leave glucose open, it will not be as if it's wet, but it does not form solution. It's because glucose is sugar and it is hygroscopic. So you could use glucose or sugar, any one of them. Honey is also there. Honey is the etc. But the ones you will likely come across are these guys. Anyway, let's continue. So that's that. Now, a fluorescent, for a substance to be a fluorescent, you know it loses water of crystallization, which means it needs to have that water of crystallization. If it does not have that water of crystallization, you cannot say that it is a fluorescent. Everybody understands this, right? Everybody understands this, right?
Yes, sir. Yes, sir.
Thank you very much. So let's continue. Now, having said this, let's come back to what we are supposed to be talking about, and that is, how do we now find the number of water of crystallization when we have an experiment? Now, when you perform an experiment to find the water of crystallization, what you basically do is you bring that salt. You don't know how many water of crystallization. All you need to do is to heat it. As you are heating it, this thing will separate into the dry salt and water. So if here used to be 2 grams and here is now 1.5, please class, what is the mass of water that is going to be produced here? I'm asking a question that requires an answer. The total salt with water of crystallization is 2. When you heated it, water separated. What is the mass going to be? If 2 here is and 1.5 is here, what's going to be here? What's going to be here? Exactly 0.5. Are you getting the point? So that's that basically. So you notice that we can actually find these amounts by considering this thing. So anytime you heat a salt, the water of crystallization is usually lost. Sometimes you will notice that when you heat this salt, let's say it was 10, not all of them would go away. It will not be entirely dry. Maybe it will remain 1 water here and then 9 will go away. So what we are going to be studying now is, how do we find this water that is lost? How do you find this water that is lost? There is a simple, straightforward formula that you can use to find this water that is lost. Now, before I even continue, I would like you to also notice this 9H2O. Does it necessarily tell us the total number of water of crystallization? I'm asking a question. When we find out that 9 water was lost, does it mean that the total number of crystallization in this salt was 9? I'm asking a question. Please answer. Wow, I just lost connection. Okay, I lost you guys at some point, right? But can you hear me now?
Yes.
Okay, so I asked.
Yes, sir.
Thank you. So I'm asking a question now. The question I asked is this. I said, you heat this salt and 9 comes out. Please, does this 9 indicate the total number of water of crystallization?
No.
Exactly. So before you say that the water that was lost is the same thing as the water of crystallization, you need to make sure that this salt was heated until all the water of crystallization was lost. Now, there are 2 ways to know that all the water of crystallization has been lost. You will see these 2 statements. They will either tell you the salt was heated, the hydrated salt was heated to a constant mass. the salt is heated to become anhydrous. Once you see these two statements, is anybody's hand up? Yes? Okay, Annie. Okay, Annie. Okay, Annie, you can talk. Annie, okay, you can go on. Or please put your hands down. Okay, thank you. Now, I said, once you see these two statements in any JAM question, it simply means that that total number of water that was lost is the same thing as the water of crystallization. Sorry, do you guys understand what I just said? Respond if you do.
No.
Okay,
No.
okay, very good, thank you.
Okay. No.
Good. Now, see what I mean. Here, shade 9 was lost. Are you following? You can unmute your mic. How many was lost here? 9, right? In this first one, 9 was lost.
9.
Good. But now I'm asking, this 9, is it the same thing as the total water of crystallization?
No.
No.
Exactly.
No.
So how do we now, so anytime you are heating a salt and this salt was not completely anhydrous, it means that this water that is lost is not the same thing as the water of crystallization. But once you begin, hello, did you get what I just said now? If you heat it and it was not heated to become anhydrous, any water that is lost does not indicate the total water of crystallization. For you to assume that this total water lost is the same thing as the total water of crystallization, they will mention in the question heated to a constant mass. Once you hear heated to a constant mass, it means that they removed all the water, and that water that they removed totally is going to give you the same thing as the total water of crystallization. Is this still confusing?
No.
Okay, good. So the point is, whenever you are looking at a question, a JAM question, and they ask you for water of crystallization, please look out for these two statements: constant mass. Then what is the second thing? Anhydrous. Heated to become anhydrous, or constant mass. I hope this is clear. Once you see these two statements, anything you calculate as the water loss is the same thing as the water of crystallization. Does it make sense now?
Yes, sir.
Okay, good. So let me now, let's try out a question. To buttress this, let's try out a question. What question do I have on this? Yeah, let's try this question quickly. Okay, yeah, I have a slide here. Let me see. Let's switch to this slide. Water of crystallization. Water of crystallization question. Oh, I probably will be sending a link in a jiffy. Okay. Okay. So, let's answer this question. It's a tricky question, but it's the same thing. Let me look at the time. We have 9 minutes, so we can solve this question. So listen, everybody. Can you all put down this question quickly? Or should I even send the slide across to you? Do you guys have this slide? I'm asking. Do you guys have like this slide? Did I send this slide earlier to the class?
Oh, no.
Okay. I probably don't worry. Let's quickly write down this question in 1 minute on recrystallization. So in this case now, you know there are two things that can happen. Is either you are collecting the water of crystallization or you are losing it. In this case, they are collecting it. You get. So finish writing this question, then I'll give you two formulas that must and will always be used. Once they are used, you get your answer. Just two formulas this time around. Just two formulas. Okay, so do that in 1 minute. If you are done, call my attention. Whoa, so sorry guys, I stepped out. Are you guys still here?
Yes.
Okay, good. So you are done writing, I guess. Are you done writing? Hello.
Yes, sir.
Thank you. Now, in 2 minutes, let's solve this question. Now, anytime you see a question associated with finding the water of crystallization, um, I'm coming up, trying to admit somebody. Okay, so this class is going to end in 3 minutes, but I'm going to send another link so that we'll join the class. So listen, there are two formulas. The two formulas are giving mass of water. Giving mass of water. When I say giving mass of water, it is the water that is given by the experiment. Giving mass of water all over giving mass of anhydrous salt. Write it in full, please. This is anhydrous salt. I'm just rushing. Equals molar mass of water times X all over molar mass of anhydrous salt. I believe this is a simple thing. Giving mass, molar mass, water, anhydrous salt, water, anhydrous salt. The second formula is giving mass of water all over giving mass of hydrated salt equals molar mass of water times X all over molar mass of hydrated salt. Have we finished writing this thing? If you feel sleepy, stand up, but this class we must hold it. Now, Na2SO4 with water is hydrated. Remove the water is anhydrous. So when you add the water to anhydrous, it becomes hydrated. Hence, anytime you are given a question and they give you a mass of hydrated salt, it is equals the given mass of anhydrous salt plus the given mass of water. Is it making any sense to anybody?
Yes, sir.
Okay, very good.
Yes, sir.
So with that said, we've understood that if we are giving hydrated salt, like if I say 2.5 gram of hydrated salt was heated to get 2.3 grams of anhydrous salt, can somebody tell me the given mass of water here? Is it not simply going to be given mass of water will now be equals given mass of hydrated salt minus given mass of anhydrous salt? Do you guys get?
Yes, sir.
Okay, so what's the answer? What's the answer going to be? Yes, what's the answer going to be?
0.2.
Exactly.
0.2.
Very good, very good. So I take it again. I'll take all this out.
0.2.
Yeah, makes sense. I'll take all this out, then we take it again. Given mass of hydrated salt is equals given mass of anhydrous salt plus given mass of water. Okay, people are now joining the class. Okay, so which means that if you are looking for the given mass of anhydrous salt, it's going to be given mass of hydrated salt minus given mass of water. If you are looking for the given mass of water, it's going to be equals given mass of hydrated salt minus given mass of anhydrous salt. Please, what I just did, I hope it is clear to everybody.
Yes, sir.
Okay, so that's that's number one. Okay, now having said that, we will go on with the question. But before we go on with the question, remember that there are two formulas. Can we remind ourselves the two formulas? Given mass of water all over given mass of anhydrous salt equals molar mass of water times X all over molar mass of anhydrous salt. Notice if anhydrous salt is here, anhydrous salt will be here. And the second formula, given mass of water all over given mass of hydrated salt equals molar mass of water times X all over molar mass of hydrated salt. Please, where you use this one is if you are given molar mass of hydrated salt. Please, when did I say you use this hydrated salt formula? If in the question you are given the molar mass of hydrated salt, use this one. But if you are not given the molar mass of the hydrated salt, please, which one are you going to use? This one. So if no molar mass of hydrated salt, use this. But if molar mass of hydrated salt is given, use the second one. Did you guys see the two reasons and the two ways to use these two formulas? Hello, students. Hello.
Yes, sir.
Okay.
Hello.
Hope you guys can hear me. Did you get what I just said?
Yes, sir.
Oh yeah, you guys should look at this question quickly. So tell me. No, that's not the question. Was that the question? Okay. Whoa, okay, no, that's not the question. So look at this question. Can you see it? Should I expand? Should I increase it?
Yes.
And they come, make I come out this thing. Okay, so you can see it now, ba? So I'm going to solve this one, then we'll solve the next one. I presume you guys have written this question before because I asked you to write it. Respond though, we don't have time. Have you written this question?
Yes, sir.
Okay, so let's get to solve. Now, once
Yes,
you
sir.
notice that you are dealing with water crystallization, all you need to do is choose the formula based on the molar mass. In this question, which molar mass, were we giving the molar mass of hydrated salt? Check. On crystallization, 20 grams of this forms 41 grams of this crystal, which is hydrated. The value of y is dash. Was there any mention of the molar mass of hydrated salt here? I'm asking the class, so answer. Is there any mention of the exactly? Because they did not mention the hydrated salt molar mass, it means that we are not going to use this thing. It means that the one we are going to use is the one for anhydrous. Is this clear? Is this clear?
Yes, sir.
Okay.
Yes, sir.
Thank you. So let's get to work. So with that said, we will now have that we'll use the formula given mass of water, which we are going to find, all over given mass of anhydrous salt. Remember, we're using anhydrous salt because we don't have the molar mass of hydrated salt. You only use the hydrated salt formula if you are given the molar mass of the hydrated salt. Let's continue. So this is going to be equals molar mass of water times x all over molar mass of anhydrous salt. Okay, let's get to work. So let's start with finding. Were we given the mass of water? Given mass of water is equals given mass of hydrated salt minus given mass of anhydrous salt. Please, is this formula correct? Is this correct? Hello?
Yes, sir.
Thank you. Now, we know that this is correct.
Yes, sir. It's correct.
So let's look at our question. According to our question, they said on crystallizing or recrystallization, 20 grams of magnesium tetraoxosulfate 6. They did not say it was hydrated. The implication is that it is only magnesium tetraoxosulfate 6 without water. Is this understood? Look at the question again. On recrystallizing, 20 grams of magnesium tetraoxosulfate 6, which means the given mass of MgSO4 anhydrous is 20 grams. So let's put it down. So given mass of the anhydrous salt, what do we have? 20 grams. That's MgSO4 without water. Should I continue? Hello, should I continue?
Yes, sir.
Good. Now, they now said, back to the question. They now said, forms 41 grams of magnesium tetraoxosulfate 6 crystal. See the formula. Please, is this one hydrated or anhydrous? I'm asking a question, class.
Hydrated.
Exactly. Because this is hydrated, it means that according to the question, the given mass of the hydrated salt is going to be 41. So let's take note of that. Okay, so let's put it down. Sorry, my pen is acting up. It's coming up. So if we put that down, the given mass of hydrated salt is going to be equals 41 gram. Now remember that if you are looking for given mass of water, you will do hydrated salt. Hydrated salt is how many? Share 41 minus anhydrous salt, which is what? 20, which means the given mass of water will be what? 21 gram. Please, is this clear?
Yes, sir.
Okay, good. So we have gotten this. Now, do we have the given mass of the anhydrous salt? Yes, it's 20. Is it not? Is it not?
Yes, sir.
Yes,
Good.
sir.
Now, does anybody, you can find the molar mass of water now. Molar mass of water is equals, is water is H2O. So it's going to be H times 2 plus 1 plus 6 plus O. This is 1 times 2 plus 16, and that's going to be 18. So the molar mass of water here will be 18. Did everybody get this in now?
Yes, sir.
Yes, sir.
So let's find the molar mass of the anhydrous salt. The anhydrous salt is just MgSO4 without water. Anhydrous means it doesn't have water. Mg is 24, S is 32, O is 16 times 4. Alright, let's get to work. What is this going to be? 24, yes, that's 64 plus 24. That's going to be, can you add that? 64 plus 24 is 88.
110,
Plus 2
110.
is 90 plus 30. Yeah, 110. Is it 110 or 120?
110.
64 plus
120.
120.
120.
64 plus
Yes.
24 is 88 now. Plus 2 is 90. Plus 30 is 120. Sure? So it's 120. So we've gotten all this. All we need to do is put this formula here. Now remember that this particular value here in this question, look, this particular value here is why we are looking for is the water of crystallization. Are you getting what I'm saying? And it was that water is the X in our own. Are you getting what I'm saying? So they use Y, but we are using X is the same thing. So let's find it. So which means given mass of water, as we found, will be 21 gram divided by the given mass of anhydrous salt. Anhydrous salt is how many? Is 20. Equals molar mass of water is 18 times X divided by, what's the molar mass of anhydrous salt? 120. Cross multiplying, X is going to be equals 120 times 21 divided by 20 times 18. So what's the answer? Check. Check. What's the answer?
7.
7. Exactly.
7.
Is that what everybody got? Please, the rest of you in this class, what did you get?
Yes, sir.
You got 7.
7.
Yes, sir. 7.
Okay, correct. So that's that basically. And this is what we
7.
thank you. This is what we refer to as Epsom salt. What did I call this salt now? Epsom salt. What did I call this salt now? Epsom. Epsom. Epsom salt. The chemical formula of Epsom salt is MgSO4 dot 7H2O, and that's that. This particular salt is majorly used as a laxative. Ogwa is the same thing you get. So just one of the constituent of your laxative drugs is this Epsom salt. Sorry, is this clear? Hello guys,
Yes,
is this
sir.
clear? Okay, you all quickly try this question in 1 minute. Failure to in 1 minute attempt this question. Oh yeah. Sorry, okay, so let me bring it down a little bit. Can you guys see it? Hello, can you guys
Yes,
see it?
sir.
Okay, good. Solve quickly. Oh, 1 minute. Your time starts. Let me time it. Let me put a timer. Your timer started though, but still. Your timer started. 58 seconds. Are you using the anhydrous salt formula or the hydrated salt formula? Yes, I'm asking a question. Are we using the anhydrous salt formula or the hydrated salt formula? Can somebody please answer my question? It's best if you answer it and you are not sure you did not get it, but keeping quiet will not mean it doesn't make sense.
The anhydrous formula,
Why are you using the anhydrous formula?
because they gave us molar the molar mass
Off.
of the
Anhydrous.
anhydrous salt.
Good. Your time is up. What's the answer? I mean the time for. Yeah. What's the answer? What did you get? Favor.
Two.
You got two. Correct. Did any other person get two? Mmaye Johnson. What did you get?
So I'm not done.
How are you not done? What exactly did you do? What formula did you use? Let's start with that. Mmaye Johnson, I'm talking to you.
Yes.
What formula did you use?
Giving mass of water divided by giving mass of anhydrous
What
salt
is the
equals
what
to
is
molar
the
mass
what
of.
is the mass of the anhydrous salt you used?
What is the
Molar mass. What's the giving mass of the anhydrous salt in this question?
2.13?
Correct. So how didn't you get your answer? Eh? Why are you
I'm not
wasting?
yet
You are taking too
done.
much
Like,
time. It's too much time. You should have been done. I give you guys, this is more than 1 minute, 30 seconds for a question that is a 30-second question. Please, is there anybody in class that did not get to? You should talk. Oh. You are in SS3, you are in exam class. You need to indicate these things. You did not get to, please indicate. Either say you did not get to or raise your hand. Please do that quickly. Unmute your mic and talk or put up your hands. Okay, so Ugu Divine Mercy, what did you get?
I'm still solving it though.
That's the problem. You are not supposed to be solving it by now. So what are you doing? Divine Mercy, I'm asking you. What formula are you using?
The giving mass of water over giving mass of anhydrous salt
Uh-huh.
equals to molar mass of water. Yes.
Okay. So you are using this. Please keep your mic on mute. You said giving mass of, because you are going to, two of us are solving it together. I want to know why you have not finished solving it.
Yes, giving mass of water. That's
Over giving mass of anhydrous salt equals molar mass of water over molar mass of anhydrous salt. Alright, let's get to work. What is giving mass of water? It is giving mass of hydrated minus giving mass of anhydrous salt, right? Yes, Divine. Are you in this class?
yes, sir.
So
Yes, I'm here.
thank you. So from what you wrote, let's look at the screen. What is the value for hydrated salt? They said 2.5 gram of hydrated salt on heating gave 2.13 gram of anhydrous salt. So the hydrated salt is 2.5 gram. The anhydrous salt is 2.13 gram. So what is going to be the given mass of water? Oh yeah. You've not done it. What's the answer? I thought you said you were solving. You did not get to this point. 0 point what?
I've got to this point.
Thank
Sir.
you. Oh yeah, giving mass of anhydrous salt. What's the giving mass of anhydrous salt? according to the question, we saw it is 2.13. Is it not?
2.13.
What is the molar mass of water? Is a constant. Now water is 18.
Yes.
Thank you. What is the molar mass of the anhydrous salt in this question? They said the molecular mass
18
is
times.
no. Molar mass of anhydrous salt. What was it giving us? Let's look at the question. 208. Is it not? Is it not?
Yes, 208.
Okay.
Yes, it
Okay.
is.
So put this in the formula and let's get our answer. So if we put it in this formula, this is going to be 0.37 divided by 2.13 times 18x. Oh, sorry, equals 18x all over 208. Cross multiply, x is going to be equals what? 0.37 times 208 divided by 2.13
0.37.
times 18.
208.
So what's it going to be? We all got 2, right?
Um,
We all got 2, right?
Yes, sir.
Okay, very good. Divine. Divine.
Sir?
I hope this is understood.
Yes, sir.
Is this understood?
Yes, sir.
Okay, we are done
Yes.
with that. Now, the next thing we are going to talk about quickly, before we get into what we have to discuss for today, is solubility curve. What did I say we need to talk about? What did I say we need to talk about?
Solubility curve.
Solubility curve.
Solubility curve.
Solubility curve.
Now, I am just going to highlight some important things. The first important thing I'm going to talk about is that solubility curve is a graphical representation. Put this down, everybody. Put this down, everybody. Put this down, everybody. Are you guys done?
Yes, sir.
Okay, very good.
Yes, sir.
Now the point is that a graph that
Yes,
shows
sir.
yeah, a graph that shows the relationship between solubility and temperature is what refers to the solubility curve. Look at something like this. And in that graph, the vertical axis is what has the solubility, while the horizontal axis has the temperature. Is this clear? Is this clear?
Yes, sir.
Good. Now,
Yes, sir.
having said this, the next thing we need to take note of are the different importance or relevance of the solubility curve. First off, it indicates the temperature at which the solution becomes saturated. Now, I hope you already know that anytime you are dealing with a saturated solution, the concentration of the saturated solution is the same thing as its solubility. Do you remember? Should I say it again? Concentration
Yes, sir.
of saturated solution equals solubility. That's another definition of solubility. So anytime you are seeing a saturated solution, it means that the highest number of solutes has entered it, and that value there is the solubility. So let's go back to the relevance. I said that the first relevance is that it indicates the temperature at which a solution becomes saturated. That's the first thing it does. It will tell you, okay, at this temperature this particular solution has become saturated. Let's see how that works. So this is exactly how it works. So let's look at the solubility. Let's look at this. So if we are to consider the curve, how are we going to find the temperature at which a solution becomes saturated? It's very simple. First off is, if I tell you that a solution becomes saturated with let's say it becomes saturated with 20 gram per 100 gram. and I want to know the temperature at which that solution will be 20 gram per 100 gram. Please just trace it to the line of the graph and bring it down. Please, what is the temperature we are seeing? Class, what's the temperature we are seeing? 60. That's that.
60 degrees.
Okay, good. Can somebody please trace that for 10 gram per 100 gram? You know this is the unit. Take note of this unit. For 10 gram per 100 gram, trace it. If you trace it,
20 degrees
it passed 20.
Celsius.
It passed 20. See where the line there. See 20 here. It passed 20. Look well. Should I increase it? It passed. Are you noticing that it's more than that?
Yes, 20 something
20
points.
something points. Good. So
Yes.
the implication is that once you check the solubility, trace it to the line of the graph and bring it down to temperature, and you get the temperature. So can I ask another question before I continue, or before I leave this? What if I was dealing with 30 gram per 100 gram? So 30 is here, ba? Let's trace together. If we trace, get to the line of the graph, we now bring it down to find the temperature. This is like middle, so it's like 90. You get the point? You get the point?
Yes.
Okay, those that just joined the class,
Yes, sir.
if you just joined the class, please indicate. If you just joined the class, please indicate. Put up your hand. Thank you. Anyone is there? And Chikwendo Miracle. Did you hear and understand what I just explained? Unmute your mics. Chikwendo, unmute your mic. Chikwendo, did you
No,
understand?
sir.
Okay, you did not understand this. Okay, Chikwendo, what about you? Did you understand this? Chikwendo, your mic is mute, so even if you are talking, we can't hear you. Okay, Chikwendo is not responding. Let's continue. So, anyone, please listen. You can unmute your mic. Unmute your mic. Shine. Thank you. So listen, I want you to join
Yes,
me.
sir.
Join me. Look at this. The first function of solubility curve is that if you have a particular solubility, it can tell you the temperature at which that particular value will be filled. That is, a particular solution will be filled by this solubility. So if I tell you that I want a solution to be filled with 20 grams per 100 gram, I will need to maintain it at a particular temperature. Let's find that temperature. This 20, trace it to this curve or this line of the graph. So trace it. What is the value here? You've gotten to the line of the graph. You now bring it down. What are you seeing as the temperature? 60 degrees. Good. If, for instance, we had said 30, what is the temperature at which this solution will become saturated at 30? You trace from 30 and take it to the line. If you bring it down, this is like in between 80 and 100, which is like 80 something or 90. You get my point?
100.
Sure you get now?
Yes.
Good. So let's continue. What is the next relevance?
Yes, sir.
Good. The next relevance is that it indicates the solubility of a saturated solution at a given temperature. Now the difference between this one and this one is that we use the solubility to find the temperature, or in this one we use the temperature to find the solubility. So let's come back to the graph. So if I say at 60 degrees, what is the solubility of this salt at 60 degrees? Please, what do? If you come to 60 degrees, trace it up, get to the line, then go left. Did you see what I did?
Yes, sir.
Good. So at 60 degrees, what is solubility?
Yes.
What is solubility?
20 more per
20.
No. Look at the unit. It's not more. This unit is not more per dm cube. That's why you should always pay attention to units. That's how they will make most of us to fail. They would confuse us with different units. So look at the units given in the question. This is 20 gram per 100 gram. I hope this is clear. Oh yeah, at 20 degrees, what is the saturation, or what would saturate it at 20 degrees? 20, trace here, then come like this. You know this is not on 10, no. This is like below 10 small, so it's like 9. Una get ba? Una get?
Yes, sir.
Yes, sir.
Okay, at 40 degrees, what will saturate it at 40 degrees? Here, trace it to this in between 20 and 10. What's the value here? What's the value here?
15.
15, correct. 15 what? 15 what? 15 what?
Gram per 100.
Exactly.
Gram per 100.
Exactly. I hope this is clear. Good. Now, with that said, we would have to continue. And anyway, let's continue. Now, guys, I hope you guys understood what I just explained, right? Is there anybody that is confused about this thing now?
Yes, sir.
You are confused?
No.
Okay, you're not confused. Chikwendo Miracle, let me hear you. Go on, unmute your mic, talk. Chikwendo Miracle, unmute your mic. Chikwendo, I cannot explain if you don't unmute your mic. Thank you.
So
Go ahead.
I don't understand what I don't
Okay.
understand how you were measuring the thing.
Is it the first one or the second one? Which one exactly?
The second one.
Okay, so look at the thing. The second
And
one says that you can use temperature to find solubility. Simple. How do you use temperature? If you find, let's say they say what is solubility at 60 degrees, you come to 60 degrees and take it up to this line, then trace it to solubility. Are you seeing what I'm doing?
yes, sir.
Good. So which means at 60 degrees, what's the solubility? Is this not 20? So the answer will be 20 gram per 100 gram. Finish. Yes? Someone's hand is up. Okay, that's Miracle. Miracle, any issue? What's up? Why is your hand still up? Miracle, put your hands down. Miracle, do you still have a confusion? If you do have, talk. Or should I continue?
Okay.
NFF, go ahead. NFF, go ahead.
Say no, it was by mistake.
It's alright. So let's continue.
Say it was by mistake.
It's alright, I heard you. Chikwendo Miracle, what's up? What's up? Oh, yeah, okay, let's continue. Now, is it, are you doing this? Okay, so probably it's just an error. Okay, let's continue. We go to the next relevance. The next relevance is that it indicates unsaturation. Values below the line of the graph indicate unsaturation. I'm going to summarize these three at once. So listen. Listen. If you have this particular cup, are you listening? And they tell you that what will fill this thing is 5 gram. Please, if what will fill it is 5 gram and I put 4.5, is this thing saturated?
Unsaturated.
Exactly. So saturated means filled, which means anything below the saturation point, anything below the saturation value is unsaturated. Anything that is exact, imagine I put 5 here. If I put 5, what is it going to become? What's this? If I put 5, is this exactly? But when I now put something like 5.5 or even 6, what is it now? It is more than the saturation, which means super saturated. Show that they get this thing back, because if you don't understand this thing, you will have problem solving questions almost all through. But did you grab this thing? Students, did you understand what I just explained? Because I'm going to questions.
Yes,
okay, good. Now everybody try this question. Try this question.
Yes, sir.
Try this question. For the graph above, put down. For the graph above. Oh, sorry, not for the graph above. Using the graph above, use that instead. Using the graph above. Determine if determine if 6 grams of the salt in dissolved in 10 grams of water is saturated, supersaturated, or unsaturated. Now I'm going to solve this one, then you solve the next one. So listen, please listen. Have we finished writing? Have we finished writing? Students, have you guys finished writing?
Yes, sir.
Yes, sir.
Okay,
Yes,
good.
sir.
Thank you. Now let's get to work. So listen. To solve this thing, they gave you mass of solute and they gave you mass of solvent. Please, the easiest way whenever they're asking you to determine saturation is convert this mass of solute and solvent, change it to the unit of the solubility in the question. So look, the solubility in this graph is gram per 100 gram. Are you still with me? Are you still with me? Hello.
Yes,
Yes,
sir.
sir.
Okay, good. We have 15 minutes now. Please, I hope you all remember. You all remember the number I gave. Once this class dismisses, send me a message, so I'll send you guys the link. We'll complete solubility today and know that okay, if we start again, we will start a new topic. There is no longer time. Are you getting what I'm saying? I hope this is clear.
Okay.
Good. Now, with that said,
Yes, sir.
this question is not actually complete. Let's see. Using the graph, that means the at 60 degrees Celsius. So add that. Add this. Add this. Have you added this? So we'll continue. Have you added that?
Yes, sir.
Good. Now, having added that,
Yes, sir.
what we are going to do now, let's get to solve. Very easy. Very easy. So listen. Once you have this, the first thing you need to do is, in this kind of question, change the mass of the solute and solvent, or anything they give you of solute and solvent, change it to the solubility unit in the graph. That's why I said pay attention to the solubility units in the graph. So we are going to change it to gram per 100 gram. How do we change it? Please, class, do you remember the formula of gram per 100 gram? What is the formula? Solubility in gram per 100 gram. I'm asking you a question, so somebody should tell me. Is equals mass of what? Solute all over mass of solvent times 100 over 1. Whose hand is up? What's up? Chikwendo miracle, what is it? Chikwendo miracle, is it that your hand is coming up without your knowing? I am listening to you. Can you please either
Is that
go on?
sir? I cannot hear you.
You can't hear me. Can every other person hear me?
Yes, sir.
Can every other person in class hear
Yes,
me?
sir.
Okay, so it's probably your network and not me.
Yes, sir.
Yes.
Thank you. So it's your network, wherever you are, is maybe has a network issue. So in those cases, when you raise your hand once, you don't need to keep raising it again. Just put it up. Once I hear it, I will respond. If I don't respond, it's because I want to round off what I'm saying. So let's come back. What did I say is the first thing everybody should do if they want to answer this kind of question? Change anything they give you in that question to the solubility unit of the graph. That's the easiest way. And I told you that since we have gram per 100 gram, changing it to gram per 100 gram is easy. Mass of solute over mass of solvent is 100 over 1. So let's go ahead. So this is going to be what? What's the mass of the solute? 6 gram. What's the mass of the solvent? 10 gram. Times 100 over 1. No be so. Hello, when I see this class.
Yes, sir.
Yes,
Good.
sir.
So
Yes,
let's
sir.
do this. Thank you. So what's my answer now? Why hasn't somebody given my answer? 6 times 10. This will be 60 gram per 100 gram. Remember, this thing is at 60 degrees Celsius. Have you seen the answer we have from the solution at 60 degrees? From this solution at 60 degrees Celsius. What's the value? 60 gram per 100 gram. Now let's check the graph. Originally, when it is 60 degrees, this solution should have how many at 60 degrees? Can we see? What should it have at 60 degrees?
20 grams
20 gram per 100 gram. But from our solution in the question, we have 60 gram per 100 gram. So let me ask, is this solution in the question super saturated, unsaturated, or saturated? What's the answer?
Super saturated.
Exactly. It is super saturated because it is higher than the value of the graph. The solubility is higher than that of the value of the graph at that temperature. Guys, do you understand? The rest of you in class, please, if you can hear me, can you respond? Do you understand?
Yes, sir.
Yes, sir.
Okay, very good. Okay, very good. Okay, you guys should try this one. Try this question. Same graph. Same
Sir,
graph.
please come again.
Come again with what? Is it the whole explanation? I want to get. What should I come again with? The whole explanation or the
thing
last
you
thing I said. Thank you. Now we got that from our calculation.
Graph back.
Thank you. From our calculation at 60 degrees, according to the question, temperature in the question is 60 degrees. We solved this and we got 60 gram per 100 gram. So at 60 degrees, this solution is containing 60 gram per 100 gram. But let's check originally what it should be At 60 degrees, what should be inside the solution is 20 gram per 100 gram. And because you have 60 gram per 100 gram instead of 20, is it super saturated, unsaturated, or saturated? Yes, I'm asking. Someone asked me to come again.
Super saturated.
It's super saturated. Why is it super saturated? Because it is
So
more.
it's super saturated.
Yes, so that's that basically. Chijioke, is this clear? Is your name Chijioke? What's your name? Clement Chijioke. Is your name actually Chijioke?
No, my name
Your name is.
is Praise.
Your name is Praise. Okay, so I will refer to you guys properly.
Praise.
Okay, good. Now, I hope this is clear. Hey, class, is this clear?
Yes,
Yes,
sir.
sir.
Okay, so I'm giving you a second question. Same graph, second question. Now, all of you solve this. Using the graph. Okay, no. Let me just change the system of question. Yeah, we could say that. 5 grams of the salt was dissolved in 20 in 50 cm cube of water at 60 degrees. Using the graph, determine if the solution is saturated, supersaturated, or unsaturated. Okay, go ahead. Yes, solve. You have 1 minute to solve this question. So look at the graph. Should I put up the graph? Are you done writing? Hello students, are you still in class?
Yes, sir.
So I have a question.
Yes, what's your question, Favor?
So in that 50 cm,
Yes.
that 50 cm, are you going to use it like that, or is there how you're going to change it to
Gram.
gram?
Thank you. Have you guys
Because you
forgotten?
did math.
Una don't forget say 1 gram of a solvent, liquid solvent, is equivalent to 1 cm cube. Do you understand? Fav.
Okay.
So anywhere you see
Yes, sir.
cm cube, you can replace it with gram. That is for your liquid solvents. I hope this is clear for everybody. So they will put cm cube to confuse you, but all you need to do is, since you have 50 cm cube, change it to gram and you solve. It's the same thing when they give you gram. When you want to solve in cm cube, change, you solve. But this is with respect to solvents, liquid solvents. Okay, the class is going to end in 7 minutes. Is there any class admin? Is there anybody in the class group that is an admin here? Chikwendu is an admin. Why is she not in class?
Yes.
Chikwendu, are you in class? Please, the rest of you, hope you have started solving. I can't see Chikwendu in class. She left. Okay. Should I put up the graph? Should I bring up the graph?
Yes, sir.
Okay, good.
Yes, sir.
So that's the graph. At 60 degrees, super saturated, unsaturated. Yes, what's the answer?
Unsaturated.
The answer is
Unsaturated.
very good. Good. So it means that when you solved it, let's solve it. The solubility of the graph is gram per 100 gram. So we need to solve this so it will be gram per 100 gram. So that's mass of solute 5 gram divided by mass of solvent 50 gram times 100 over 1. If you do this, this is 2. So this is going to be what? 10 gram per 100 gram at 60 degrees. Now let's check the graph. The graph says that at 60 degrees, what should be there is 20. But from the solution, it is 10, which means it is not filled, it is unsaturated. And that's that. Hope this is clear. Hope this is clear.
Yes, sir.
Yes,
Now,
sir.
the next thing you can use the graph to do?
Yes.
Yes, sir.
Thank you. The next thing you can use solubility curve to do is that it can be used to determine or find the amount of crystal for a given decrease in temperature. It can be used to determine or find the amount of crystal for a given decrease in temperature. It can be used to determine or find the amount of crystal for a given decrease in temperature. It can be used to determine or find the amount of crystal for a given decrease in temperature. Okay, should I continue? Should I continue? Now,
Yes, sir.
see what happens
Yes,
here.
sir.
If we want to know, I've already told you guys before now. If you do not know this thing, I'm saying it again. That if you have solubility, if you reduce temperature, solubility reduces. And solubility is the amount inside. So if we say that at 25 degrees Celsius, what is inside is 5 grams. And then I now tell you that I reduce the temperature to 10 degrees Celsius. Please, what should be inside will not more be 5 grams. It should reduce. When temperature reduces, solubility reduces. So what will be inside here? I'll be like 3 grams. Are you people still following me?
Yes, sir.
Now, if I ask you, what is the amount that came out of this solution? Who can tell me? What is the mass that came out?
Gram.
Exactly. And that's what we refer to as the amount of crystal. What do I refer to it as? The amount of crystal. So the formula for amount of crystal is solute at higher temperature minus solute at lower temperature. And that's that. The other way to solve it is solubility at higher temperature minus solubility at lower temperature. Are we there? Are we still here? Are we still here?
Yes,
Yes,
sir.
sir.
Very good. Please,
Yes, sir.
Yes,
is
sir.
Chikwendo in class? Is she in class? She's not in class. Okay. Do I have any other admin of the class group here? So what I'm going to do is, one of you would have to chat me up. We'll end the class now. To continue to finish up, we'll end by 11:30. I'll end the class by 11:30 so you all can sleep. So I'm going to send a third link. So chat me up. I'll send the link to anybody that chats me up. Chat me up, then I'll send the link. Then anybody here can push it to the group, and every other person can join. I hope this is clear. So I'm ending this class now. Of crystal. It's very simple. It is going to be given as solute at higher temperature minus solute at lower temperature. Now, if they give you solubility, you can simply do the difference in their solubilities once the two solubilities are the same thing. If the solubility at higher temperature is gram per dmp and solubility at lower temperature is gram per, you can just do it, because solubility, anytime you see solubility, hope you know it is solute over solvent. So all you need to do is take this solute and then you find your answer. Are you getting what I'm saying? So once they give you solubility, you simply take the upper one, and that's that. So if I tell you that solubility is 20 gram per 100 gram, please, what is the solute here? 20. If I tell you that it is 10 gram per 100 gram, please, what is the solute here? 10. Are you guys following what I'm saying?
Yes, sir.
Okay, good. Now remember, amount of crystal. What did I say is the formula for amount of crystal? Solute at higher temperature and solute at lower temperature. Is this clear? Is this clear?
Yes, sir.
Okay, good. So let's take this out and then solve the question. Let's solve the question. Now imagine I say, for instance, look at this question, that this particular solution was cooled from 60 to 20. This solution X was cooled from 60 to 20. What is the amount of crystal? Can somebody tell me? What is the amount of crystal?
40.
You are not serious. You don't know what I'm saying. It was cooled from 60 to 20. What is the amount of crystal? Amount of crystal. What is the formula? Is it not solute at higher temperature and not solute at lower temperature? So 60 is the higher temperature. What's the solute at 60? What's the solute at 60, class?
20
20.
grams per
Thank you.
100 grams.
So put it down. Then the solute at 20. This is like 9. Let's call it 9. So let's get to work. So we'll now write amount of crystal has an original formula of solute at higher temperature. Amount of crystal. Now sometimes they will not call it amount of crystal. They will say amount deposited. Now the same thing. Is equals solute at higher temperature minus solute at lower temperature. So let's get to work. The amount of crystal will now be equals what? Alright, let's get to work. So we have the solute at higher temperature, which is 60 degrees. What is solute at 60 degrees? 20. You know they said the solubility is 20 gram per 100 gram. But please, the solute is the one on top, and that's why we're taking it 20 gram. Then at the lower temperature, which is 20 degrees, we have 9 gram per 100 gram. But the solute is this one on top, so we're taking 9 gram. So please, 20 minus 9. Class, what's the answer? 11 gram. Is this understood? Hello? Is this understood?
sir.
Okay. Now there's a tricky
Sir,
aspect.
I don't understand.
Oh, so who is talking? You don't have to raise your hand. Please, who is
Sir, I
talking?
don't understand.
Who is talking? Identify
Sir, I
yourself.
don't understand.
I say, what is your name?
I've
Who
raised
is?
my
I did not say you should raise your hand. I want your name. What is your name?
and where is the chine?
Okay, thank you very much, Chine. So Chine, you are confused about what exactly? Is it the formula that is confusing you?
No, sir. It's how you solve it.
Okay, so let's take it again. The higher temperature, according to the question, is 60 degrees. The lower temperature is 20 degrees. Let's find the solute at 60 degrees. Alright, let's go to the graph. At 60 degrees, the solubility is 20 gram per 100 gram. True or false?
True.
Okay, so which means if we are to come here, you will notice that at 60 degrees, 20 gram per 100 gram is equal solubility. But please, is this not the solute? Remember, solubility is solute name, solvent name. So which means the solute is actually this one on top. So at 60 degrees, 20. Agreed? Agreed?
Yes.
Then at 20 degrees,
Yes, sir.
let's check at 20 degrees. 20 degrees is not 10. This is like 9. It's below 10. Trace it. It's like here. So this is like 9. So that's why we said at 20 degrees, which is the lower temperature, we have 9. So which means at 20 degrees, it is going to be 9 gram per 100 gram. But please, the solute is the one on top. So that's why we chose 9. Is it clear? Anyone is it? Are you still with me? Have you left the class?
Sir,
Good.
it's clear.
It's clear now. Good. Now, is there any other confused person in the class, or should I just continue? Should I just continue? I'm asking, should I continue? Vivian and the rest of you.
You can continue.
Okay, very good. I'm sorry. Now, the next thing, let's try out a complicated question ish. A question that will test our brains more. A question that will test our brains more. Just something that will test our brain. I think this one should be able to test our brain. Oh yeah. Oh. Okay, so look at this question. Put it down first. Put it down first. Quickly, don't waste my time. There's no time. Wow, it's almost 11:30. Should we extend or end class by 11:30?
So we can extend it.
Okay. The rest of you, do you think we should extend? So that we'll finish this thing today and we'll start something new next class. Eh? Hello.
Can understand.
Okay. I'm sorry. Are you guys done writing?
Yes, sir.
Okay, very good. Okay, so let's continue. Now, the question says the diagram above is the solubility curve of solute X. Find the amount of X deposited when 500, please emphasis, when how many? 500 cm cube of solution X is cooled from 60 degrees to 20. Alright, let's look at the graph. See the graph. Can you see the graph? Can you see the graph? Please, is the graph clear to everybody?
Yes,
Yes,
sir.
sir.
Okay.
Yes.
Oh, sorry. Oh yeah. So let's check. At 60 degrees, let's trace it up. This, let's check this first. This 2, 4, 6, which means this is 5 is here. You know that 5 is here now. Uh, is it
Yes,
not?
sir.
This is 1, this is 1, this is 3. So let's check this. At 60 degrees, if we trace it to here, this is 6, this is 5. In between 5 and 6 is 5.5. So which means at 60 degrees, we have 5.5. Do you agree?
Yes, sir.
Yes, sir.
5.5 what? Mole per dm cube. That's why I said always take note of the unit. So
More
let's
per day.
let's let's put that down. So which means for this particular question, at 60 degrees, at 60 degrees, we have 5.5 moles per dm cube. Please hope you know per dm cube means in 1 dm cube. Now, but the question did not say 1 dm cube of the solution. It said 500 cm cube. Are you seeing what I'm saying? So we are not supposed to use the solute in 1 dm cube, but the solute in 500 cm cube. Sorry, do you guys understand?
Yes, sir.
Okay, now there are two ways to do it. The first way is you simply say if 5.5 moles is in 1 dm cube, hope you know 1 dm cube is 1000 cm cube. If 5.5 moles is in 1 dm cube, therefore how many will be in 500 cm cube? Oh yeah, because we are dealing with 500 cm, so we need to find the amount in 500, not in 1 dm cube. Cross multiply. X is going to be what? This should be 2.75. Is this confusing? Hello, students.
sir.
So I should continue, right?
Yes, sir.
Yes, sir.
Okay, good. Now, having said that, what was I even saying? So we have 5.5 moles in 1 dm cube. Yeah, okay, so let's go to the next one. Let's check. Say they said from 60 to 20. So 20 is on 4. Are you not seeing it's on 4? She has seen it's on 4. Can you guys see it now?
Yes, sir.
Okay, so which means that we'll have at 20, it is equals 4 moles per 1 dm cube. But we're not dealing with this, we are dealing with 500 cm cube. So which means we are going to say if 4 moles is in 1000 cm cube, how many moles will now be inside that 500 cm cube that the question says? Because the question says 500 cm cube. So which means X is going to be equals 2 moles. Una equate. Una equate.
Yes, sir.
Good. Now, remember that the question
Yes,
says,
sir.
let's go back to the question. What did the question say we should actually find? The question says that we should find the amount of X, that's the amount of crystal, when you cool from 60 to 20. Please, how do you find the amount of crystal? Do you still remember? Yes, how do you find the amount of crystal? I'm asking students.
Probability at high temperature minus
No,
probability at low temperature.
no, that's not what I said. I said solute. not just solubility.
So
When I
that's the first one.
Yeah, the solubility I gave you is, if they gave you one dm cube and the solubility is in mole per dm cube or gram per dm cube, you can use that solubility to solve. But the actual formula is solute at higher temperature minus solute at lower temperature. Now please class, what is the solute in 500 cm cube at lower temperature, at higher temperature? What do we have? 2.75 moles. Should I continue? Minus
Yes, sir.
the solutes in 500 because the question emphasized 500, that's why we changed it to 500 cm cube. So in 500 cm cube, what is the amount in mole at the lower temperature? 2 moles, which means the amount of crystal will be equals what? 0.75 moles. Shown again.
Yes, sir.
Good,
Yes,
very
sir.
good, thank you. So I hope this is clear, because you guys are going to be attempting questions later on. Okay, so with this said, let's continue. Now let's try out another thing, or let's look up another relevance of solubility. The other relevance of solubility curve is this: it can be used to compare the solubility of multiple salts. Note, the steeper the curve, the higher the solubility. Please, what did I say you should take note of? The steeper, that's when the curve is more bent, it means that the solubility is higher for that given range of temperature. So this is what we mean. If you look at this particular diagram, you will notice that there are many salts that are relating here. So I can ask a question. Look, see this question: at what temperature is the solubility of potassium chloride and potassium heptaoxodichromate 6 the same thing? At what temperature is the solubility of potassium chloride and the solubility of potassium dichromate 6 the same thing? You are looking at where they cross. So where they cross, you bring it down. Where they cross, you bring it down. This is like 70 something, right?
Yes, sir.
Exactly. So that's that.
Yes, sir.
Does it make sense? Hope it makes sense.
Yes,
Okay, let's ask another question. The question I'm going to ask again is, which one of these will have the highest solubility within the range of below 30 degrees? Which of these salts has the highest solubility below 30 degrees? Remember what we said. Note. What did I say you should note? The steeper the curve, that's if the curve is more bent, it means that it has a high solubility. So we said for the range of 0 to 30, which one of these salts in the range of 0 to 30 is most bent? Has the highest solubility, which means the one that has the most bent curve is the one that has the highest solubility. Please, what's the answer?
calcium chloride.
Exactly, that's the answer. I hope this is clear to everybody. I hope this is clear to everybody.
Yes, sir.
Okay, let's now answer this question. So I'm going to help us answer this question because it's a technical question, but this is the last one I'll answer, and then we'll talk about solubility products and end the class for today. So listen. Consider the solubility curve of 3 salts, X, Y, and Z. What are the 3 salts I said you should consider? X, Y, Z. Anytime I'm answering a solubility curve question, I like writing out the things as I'm answering. So let's start writing it out. So let's take this out. Consider the solubility curves of 3 salts, X, Y, and Z. Let me remove this. X, Y, and Z. So let's continue. So they now said, given in the diagram. Okay, so let's see the diagram. So this is the diagram. What can you get from this diagram? The implication is that the one that is most, for instance, now if I ask you at 40 degrees what's solubility, you drag it from here. You notice that at 40 degrees is like below 100-ish for Z, but at 40 degrees for Y is above 100. At 40 degrees for x is above 157. It's close to 200. Do you guys get what I'm doing?
Yes, sir.
Okay, good. But
Yes.
that's not
Yes.
the question. We have considered it. Let's go back to the question. So the question says, consider these things, and we have considered it. They now said, if each solution contains 200 gram and is heated to 100 degrees Celsius, so which means at 100 degrees Celsius, what is the solute inside each of the solution? 200 grams. So let's put that down. So at 100 degrees Celsius, x has 200 gram, y has 200 gram, z has 200 gram. Shey una follow wetin I just do? Hello students, are you here?
Yes, sir.
Yes, sir.
Good.
Yes, sir.
You have slept. Somebody has slept. If you are here and you have slept, please raise your hand. I will not flog. Just raise your hand. Indicate. You know you are feeling sleepy. Oya, raise hand. Oya, somebody's hand is up. Exactly. Mma Yechin also. Thank you very much. Who else is feeling sleepy? Who else is feeling sleepy? So Mma Yechin also. Do you people have biscuits, garri, chewing gum in your house? You have all this kind of thing.
Yes, sir.
You can go and pack garri and start chewing. You will not sleep in Jesus' name. Okay, so you can stand up. Stand up. I want you to grab this thing. So let's continue. Now listen, Mona, listen. So let's come back to the question. So the question now says heated to 100 degrees. So 200 gram at 100 degrees. They now said which solution or solutions will deposit more than 100 gram of solute when it is cooled to 0 degrees. So let's go back to our drawing board. So they said when we now cool it to 0 degrees, first of all, when you cool it to 0 degrees, let's see what will happen. If you cool it to 0 degrees, Z will now be what value? See where Z is. 0 degrees. Z is what now? Z is below 50. What are we going to call this thing? 40 what? Yes, now. What value is here? It's below 50. What are we calling it? 40. It's not 46, is too close to 50. So let's call it 41. You get? Any value you still call it, provided it's below 50, you will still get it correctly. So Z is 41 gram at 0 degrees. Let's check Y. Oh yeah, Y is below 100 but it's above 50. So this is like 90 something, bah? Yes, what do we think? Favor and the rest of you, are you still in class?
Yes, sir.
Yes, so what do we think? At 0
95.
degrees. Let's call it 95, okay? Let's call it 95. Then for X, what do we think? X is way this is above 150 now. So 170 something. Che? Right?
Yes, sir.
Okay, now what's the amount that will deposit here? Remember, amount that will deposit solute at higher temperature minus solute at lower temperature. Oh yeah, minus this. Let's get the amount. The amount that will deposit here is 159. Ba? Here is 105.
Yes.
And here is like this is like 28. This amount deposited. Okay, are you all still following? Are you
Yes, sir.
all still sleeping?
No, sir.
No.
Okay, good. So please, we have gotten that the one deposited from X is 28, from Y is 105, from Z is 159. Let's go back to the question. The question says, which of the solutions or solutions will deposit more than 100 gram of solute when cooled to 0 degrees? So please, can you tell me what's the answer? What's the answer?
Why?
Only Y?
Why? Z.
Y and Z, correct. If I ask a question, which one of these solutions will deposit less than 100 grams when cooled? What's the answer?
X.
X.
Good. Which one of them will deposit more than 100 grams but less than 150?
Why?
Less, oh sorry, more than 100 grams but less than 150. Why? Which one would deposit more than 150 but less than 200?
Z.
Z.
Exactly. Sorry, is this clear to everybody? So let's check our options.
Yes, sir.
So what's the answer? Look at your options. What's the answer? Let's take this up a little bit. What's the answer?
E.
Exactly.
Y and Z. E.
And that's that. Finally, solubility product. Finally, for today's class, solubility product. Please put this down. It's important. Now write what you have on your screen quickly. So I will now give you the formula. We try out 2 questions and call it off for the night. Are you done writing?
No.
Okay, be fast. Sorry, I'll be back. I'll be back.
Chine. You know,
Yeah,
yeah.
the class so good, you know, but
Shut up, your mouth. Now we're only four.
keep it
We're only
cool.
four in this class.
Nah, it's only four. I don't know if everybody went. Or you see that they don't know that it's class or what?
I was calling them, none of them picked their calls. It's only Mimi. Mimi said that she's having network issue. But Philip,
Nice.
Obioma, Ewuchisom, none of them picked their call.
Okay, I presume you guys are done.
Yes.
Good. Now,
Yes,
for you to understand solubility product, you need to understand equilibrium constant. But I'm not going to teach it in this class. I'll talk about it some other time. I'll just give you the straightforward formula to solve for solubility product. Now, solubility product is simply the equilibrium constant for a dissolution process. Which means if I have this substance, CXDY, and I dissolve it, it is going to give me C positive plus D negative. How many C do I have? X. How many D do I have? Y. Can you all see this?
Yes.
Good. Now,
yes, sir.
whenever I say solubility product, it is the same thing as the equilibrium constant for a dissolution process. And the equilibrium constant for this dissolution process is going to be concentration of C positive raised power X times concentration of D negative raised power Y. When we do equilibrium constant, you understand? So this is the first formula 1. Put this down. Put this down. Put this down. Are you done? Are you done?
Yes, sir.
Okay, so we go to the next one. Now, concentration of any ion is equals solubility of dissolved salt. Now, if they don't say solubility, you could say concentration of dissolved salt. Concentration or solubility of dissolved salt multiplied by number of moles of cation. So, which means anytime you are looking for the concentration of C, it's going to be S, which is the solubility of this salt that we dissolved. Remember, the salt is CXTY multiplied by the number of moles. Please, what's the number of moles of C? X. Is this clear?
Yes, sir.
So who can tell me the formula for the concentration of D minus? It's going to be what? Solubility of Cx dy times what now?
Wow.
Exactly. So that's that. So just have that in mind. So with this said, you can now write S is equals solubility or conc of dissolved salt. Please stay awake. This is the last part. Then you now write X is number of moles of cation. Y is number of moles of anion. Okay, have you written these ones? Because we are not done. This is the first formula you need to know, but this one will be harder for you to solve. So I'm going to break it down so it will be you have a very easy formula that you will use to get this formula. Now you will not see it in any of your textbooks, so just take note of that. That's why I want you to learn it now. Well, those of them that missed the class, I'll have to put out a record. I'm recording this, so they will have to see it later. Okay, are you done? Are you done? Because I want to remove this thing and continue solving.
No, sir.
Please be fast. There's no time.
Sir, we are done.
Okay, so now having said this, we are going to try to use this to show a direct relationship between solubility product and solubility. So you have K of S of P is equals this guy raised power x and this guy raised power y. But you already know that this guy, which is the cation concentration, is S times x. So anywhere I see C, concentration of C, I'm going to put S times x. Remember that it is still raised to power y. Anywhere I see D, I'm going to put S times y. Still, all of them raised power y. Are you following? Are you following? Good. Now, the implication is that
Yes, sir.
if we expand this with indices, this will be S raised power y times x. Oh no, this is x now. I forgot. Share is x. It's x that is here. So it's x raised power x. Are you following? Times x raised power x times s raised power y times y raised power y. Collecting like terms, k of s of p will be s raised power x. Is it not? Times s raised power y times x raised power x times y raised power y. If I continue, this would mean s raised power x plus y times x raised power x times y raised power y. Put down this formula. So even if you don't understand what I did, just put this formula down. This one. solubility product is equal to solubility raised to power x plus y times x raised to power x times y raised to power y. Are you done?
Yes, sir.
Yes, sir.
Okay. So anytime you are giving solubility and they say find solubility product, please use this thing straight up, you get your answer. Now can we make solubility the subject of formula? Yes. If we make solubility the subject of formula, it will now be k of s of p divided by x raised to power x times y raised to power y, which means solubility alone will now be root x plus y. This is mass, so if you don't understand it, it's not chemistry, it's mass. K of s of p divided by x raised to power x times y raised to power y. Clear? Is this understood?
Yes, sir.
Okay, good.
Yes, sir.
So we're going to try out a question. But before we try out that question, have this in mind. Once you see solubility product question, first thing is dissociate the salt and find out. Remember, I said x is number of moles of cations, y is number of moles of what? Anions. This one is what? Cations. It's important you take note of these two things. Once you know these things, it's easier. Can I continue? Should I continue?
Yes,
Hello.
sir.
Okay, good. Now with that said, let's try out this question. Please, you guys are done writing now.
So we are right.
Oh, you are still writing. Okay, write that down quickly and get back to me quick. Once you are done, tell me. So I would. Please be fast too. I want us to finish this
So I'm
thing.
done.
Is it
So
are the
we
rest?
are done.
Okay, good. Now let's
So we
try.
are done.
Let's try this question. So we're going to try two questions and we'll call it a day. Sorry. So the question says, a saturated, can you see the question, class?
Yes, sir.
Okay, so please put this down quickly so I will solve. I'll solve this one, you guys will solve the next one. Alpha, are you guys done writing? Just the question, you don't need to write the options. Are you
So we
guys
are
done?
done.
Okay, good, good. So let's continue. Now, with that said, let's solve the question. Now, the first thing I said you should do whenever you have this thing is that you should write out the dissociation equation for the salt. The salt we are dealing with here is what salt? Is it not AgCl?
Silver chloride.
So AgCl, let's break it down. AgCl will give us Ag plus
Silver
plus Cl minus.
chloride.
Thank you. Now please, what is X? Hope you know is 1. What is Y?
It's cool.
1.
Why?
Hello, sorry. I hope you are still with me.
Yes, sir.
Is anybody sleeping?
No.
Okay, good.
No.
So let's continue. Now, if I had written, let's see something. If I had written CaCl2, hope you know it will be Ca 2 plus Cl minus, because this number is the charge for this guy. But we're not considering the charge. Let's balance it. How many Ca is here? Is 1. How many Cl is here? Is 2. So we put 2. So what's X here? What is Y here? What's y here? If I have Al2 SO4 all brackets 3, hope you know if it dissociates it will give Al3 plus SO4 2 minus. How many Al is here? There are 2 of them, so we put 2 here. How many SO4 is here? There are 3 of them, so we put 3 here. So if I ask what is x here, x is 2, y is how many? 3. Should I continue?
Yes, sir.
Okay, so I'm taking this out, so I will solve. So having done that, that's the first thing we need to do. Dissociate it and find your x and y. Once you find your x and y, you now come back to the question. Alright, let's go back to the question. Let's see what the question says. So the question says a saturated solution of AgCl was found to have a concentration of 1.30 times 10 raised to the power minus 5. Please, this concentration is the same as the solubility because they said saturated solution. Hope you remember that once a solution is saturated, the concentration is the same thing as its solubility. You remember I said it in the beginning of the class, right?
Yes, sir.
Okay, full stop. So the solubility is 1.3 times 10 raised to the power minus 5. They now said the solubility product is dash. Please, what is the formula for solubility product? K of S of P. K of S of P is equals S raised to the power x plus y times x raised to the power x times y raised to the power y. Is it not? Is it not? X is 1, y is 1. Solubility is what? 1.3 times 10 raised to the power minus 5. Shebi, I'll put it here. So K of S of P would now be, what's the solubility? 1.3 times 10 raised to the power minus 5. All raised to the power, what is x? 1. Plus, what is y? 1. Times, x is 1 raised to the power 1. Times 1 raised to the power 1. Okay. So the solubility product is going to be 1.3 times 10 raised to the power minus 5. 1 plus 1 is 2. Times 1 times 1. So what is K of S of P going to be? Please, can you calculate this? What's the answer? This should give us 1.69 times 10 raised to the power minus 10. And that's the answer. Is anybody confused? That's option C. Is anybody confused? Is anybody confused?
No.
Okay, very good. I try this question, everybody. That's the last question for the night. Try this question. Please, you see this thing they wrote here. Assuming neither, just ignore it. Now you are looking for solubility. Hope you know that the formula you are going to use, if it's solubility you are looking for. If you are looking for solubility, what will it now become? Solubility is equals root x plus y K of S of P divided by x raised to the power x times y raised to the power y. Sure, you know. So if you add these two things, that's the root. Like if this is 1 plus 2, you know it's cube root you use here. Hope you know. Hello, students.
Yes.
I said if this is cube root, I said if you have 1 plus 3 here, x is 1, then this is 2. That's 3 now, which means cube root, right?
Yes, sir.
Yes,
If you have 1 and 4, is to be fifth root or penth root. I don't know what they call it. So solve. Oh, yeah, solve now. Solve. Look at the question quickly. That's the last question for tonight. Yesterday. Are you guys not done solving? Are you guys not done solving? Nobody has gotten an answer. Any favor? Anywhere? Vivian? No answer.
Okay. So
What did you get?
I've not finished.
No, you can't tell me that. Oh yeah, let's solve this together. It's either you people don't know what you people are doing. Oh yeah, let's solve it together. This is a very simple thing. Oh yeah, before this time elapses, let's solve it. Please, class, the salt we are dealing with is what? Cu bracket IO3 bracket 2. So let's dissociate it. Cu2 plus IO3 minus. Please, how many Cu do you have? Is 1, ba? So 1. How many IO3 do you have? You have 2. So class, what is X? I'm asking, what is X?
1,
1. What is Y?
2.
Exactly. Now, please, you were asked to find the solubility, but you are given the solubility product. So what is the solubility product in this question?
1.08
Times 10 raised power
minus 7.
minus 7. Very good. Now let's get to work. Solubility is equals x plus y root of k of s of p divided by x raised power x times y raised power y. This formula is not in any textbook. So if you miss this and they give you a question on this, you don't miss with that. So listen. So let's add this. X is 1 plus y, which is 2, which means you are going to do cube root. Is it not?
Yes, sir.
Good. K of S of P is 1.08 times 10 raised power minus 7 divided by x is 1 raised power 1 times y, which is 2 raised power 2. If you do this, solubility will now be equals cube root of 1.08 times 10 raised power minus 7 divided by 4. Are we still with me?
Yes, sir.
So this is going to be
Yes.
cube root of, without calculator, if we change this will be 108 times 10 raised to power minus 9 divided by 4. Cancelling, this should give us 27. Cube root of 27 is 3. Cube root of this guy is 10 raised to power minus 3. That's the answer. Is it clear?
Yes, sir.
If you got this or something close to this, can you please raise your hand? You are about to get this. Can you indicate? Oh, nice, nice. Any other person? Okay, very good, very good, very good. Okay, Vivian and Favor. Is it clear?
Yes, sir.
Okay, we'll end class here for today. See you guys in the next class. Now, please, I'm giving you a read up. Your read up for this week. How many elements have I given you guys? I've not given you guys any elements. Have I?
Hydrogen and oxygen.
Thank you. Now you are adding nitrogen.
Yes.
You are adding nitrogen and carbon. What did I say you should add? Nitrogen and carbon.
Nitrogen and
Thank you. In my next class, we'll start with that. We'll start with a test. Thank you very much for joining my class. See you guys next week.